Good afternoon, Frau McAtee. Good afternoon, class. My name is Kevin Wayne Owens. I'm a former senior airman from the United States Air Force who was a weather forecaster for 6 years. And today I will be teaching you all how to encode weather observations, METARs, as well as decode METARs and terminal aerodrome forecasts. METARs are weather observations taken at an airport. These are used in everything from models to climatology. And terminal aerodrome forecasts are, well, forecasts that are used primarily for aviation, and these are the most accurate products you are going to get. They're valid for 36 hours, and they are from 10 miles of the airport. A bit of credibility about myself: from 2010 to 2011, I was the East Coast forecaster for Georgia, Florida, South Carolina, and North Carolina at the 26th Operational Weather Squadron, Barksdale Air Force, Louisiana. No notable weather events occurred during that time, aside from a few hurricanes and some severe caused by air mass thunderstorms. After that, I was moved to the X-Flight, which was flight weather briefing and graphics. I did such an impressive job that I was moved to flight weather briefer and graphics manager ahead of schedule, during which time the Joplin tornadoes occurred. I put out the warning 15 minutes before National Weather Service did for our military aircraft. We created several new products that are now being used at National Weather Service. After I did my time there, they moved me into battlefield weather, which I moved to Wiesbaden, Germany to perform that duty, during which time I was the forecaster for the Russian invasion of Crimea, as well as the forecaster for the Ebola incident in Africa. My job consists a lot of briefing a 4- or 3-star general, in addition to our normal air flight duties and training other forecasters in what I am teaching you today. Sample METARs and TAFs. I have the Fayetteville METAR and TAF for today, as well as the Barksdale Air Force Base TAF and METAR for today, as well as the Frankfurt am Main METAR and TAF for today. These are all available via ads, and we will be going over all of these, what makes them unique, and how to decode them. So first things first, in any METAR and TAF, you're going to have your basic data, location, time. So example, KFYB is Fayetteville. Time would be first 2 digits are your date, your set. Again, 4 followed by the Z is the time in Zulu. That is the time along the prime meridian. Anytime you see a K prefixing the final 3 letters, that means it's in the US. If you see an E, that means it's in the EU. For example, KFYB means Fayetteville, Drake Field. KMAGE is Dobbins Air Force Base. KBAD is Barksdale Air Force Base. ETOU is Wiesbaden Army Airfield, Germany. And yes, that is a US base. You'll also see a follow-up with an auto. It just means it's automated. The weather sensor is doing all the recording of the data. Winds, example 25015, gets 25 knots. 250 is the direction. Basically, picture north as 12 o'clock. That's 0 degrees if the winds are calm. 360 is if they are from the north. Keep going around. Every 90 degrees is a different direction. 090 is east. 180 is south. 270 is west. The second 2 to 3 digits are your wind speed in knots. I've never seen anything over 100 knots, so don't worry about it. And then your G followed by 2 to 3 digits. That's just your gust. That is usually about 10 knots higher, but I've seen it as much as 50 knots higher. Various ways to forecast this is the Buford wind scale, which is this if you are doing it manually. I know on land it says calm, smoke rises vertically, smoke drift. Do not start a fire. A cigarette works a lot better for this. Then you move on to VIS. In the U.S., this is reported in statute miles, 10 statute miles being the max. Overseas, it's in meters, as well as in U.S. territories, Alaska, and Hawaii. 999 is completely unrestricted. If it is anything less than 7 or 999, you need to have a weather restrictor with this. If you do not, you will have to cord the off. The weather restrictor, also known as present weather. In this case, this plus TSR-AVR means thunderstorms with heavy rain and mist. That plus means heavy. There is no such thing as heavy thunderstorms or heavy mist. The majority of these are 2-letter codes. They're all in English with the exception of mist, which is BR, and smoke, which is FU. This is from the AFMAN 15 TAC 111, table 1.3, or table 13.1. This is just all your various weather codes. It's the same across the world. Due to AMS, WMO, and military, these never really change. Sky condition heights. Example SCT 250 is a scattered cloud layer at 25,000 feet. These are determined by how much of the celestial dome is covered. The celestial dome is divided into 8s. You have few, scattered, broken, and overcast. During the day, this is really easy to do. At night, I honestly recommend learning your constellations and using them. That's what always worked for me, and when I was having to use the constellations, I was literally in the middle of the woods in Latvia. So your first digit in your sky condition, so 250, 2 means tens of thousands, 5 would be thousands, and 3 is hundreds. We don't go into tens of feet. That gets more into vertical visibility. You'll only see that with fog, and even that's not too common. Finally, your altimeter, temperature, and dew point. In the U.S., and this does include Alaska, Hawaii, and U.S. territories, this is recorded in inches of mercury and is prefixed by an A. And my first example, A2991, basically means 29.91 inches of mercury. That's standard altimeter. Anywhere else, this is prefixed by a Q and is recorded in hectopascals. So in this example, 101.3 standard altimeter in hectopascals. In military tasks, which is not in any civilian tasks either here or overseas, we also record the lowest altimeter during the valid time period. So that's prefixed by Q and H and suffixed by I and S. Altimeter and dew point are always in Celsius, always. In this case, they're recorded as 10/09 in observations. Military tasks are also the only ones that include your max and min temperatures. Temperatures are prefixed by a TX for max, followed by the time, and a TN for min. Common METAR remarks: always look at your AFMAN 15 TAC 111. This literally has everything you will need, whether or not you're working civilian, military, in the U.S. or outside the U.S. The most common ones is AO2 and AO2A. AO2 means automated. AO2A means that the forecaster has gone out and actually confirmed something that the sensor can't read. For example, tornadoes or hail. If you are having to confirm hail, remember the largest hail always falls closest to the door. Light and distant is usually followed by whatever direction the lightning is being seen and what direction it's moving. This is actually used to verify things like lightning warnings or advisories. Core simply means the ob has been corrected. If there are no questions, that concludes my briefing.